Good afternoon. Welcome to the first session of a series of lessons about problems and solutions in the agriculture industry. I don't know about you, but I'm particularly interested in the agriculture industry when I'm hungry. All of us experience hunger at some point, whether it's that we can't wait for this class period to be over and lunch to start, or that we don't know where our next meal is coming from. There are many types of hunger, and most everyone in the world experiences at least that gnawing in their stomach at one point in their life. There's some statistics listed on this slide that are a bit alarming, though, and kind of reinforce my passion to understand hunger as it relates to people being food insecure. 12% of the population in the US currently struggle with hunger. That's about 41 million people. There's about 38 million Americans that struggle with poverty, and we find that being food insecure and struggling with poverty go hand in hand. Many of them are households with children that don't have both a mom and a dad at home. About 16% of all children don't know where their meal is coming from. And perhaps this one's the most motivating to me because oftentimes children receive the consequences of choices that weren't theirs. About 22 million a day rely on school for particularly for school lunches and school breakfasts. We even have about 12% of the senior citizens around us that are food insecure. Now, most people that are food insecure are doing what they can to work towards it. And so we know that there's actually an average monthly income that even those people who use food assistance programs are making a little bit of money each month. They just can't make it cover all their costs. Coincidentally, there are actually some states that struggle with higher rates of food insecurity. And even in the places that aren't struggling, the cost of a meal in America is relatively high compared to other countries. And we see this number actually climbing in recent years due to some different inflation problems. All of these statistics came from a website called thebarbecuelab.com, and I would encourage you to go take a look there. They actually are kind of a clearinghouse for all sorts of statistics about hunger and food insecurity and who is struggling in the United States. They do a great job of compiling that information. One of the things that I think is worth considering when we think about agriculture and hunger is also population growth. This graph shows us how the world's populations are growing. If we start looking on the left side at about 1820, it ends just recently in 2021. And we notice in that first 100 or so years, we see very, very slow growth of populations. Um, you can see by color, they are linked to continents. And so always the larger population sector has been in Asia. And then you can see that thin pink line of Africa, Europe, and then later in time, we have more growth in South and North America. The thing that's worth noting is that population grows exponentially. And so we see those growth curves get pretty steep as they get closer to the present, and we see them change in size. So while North and South America remain particularly small portions of the graph, and Europe stays pretty steady, we see a pretty good change in growth for both Africa and Asia. The current world population is 7.9 billion. And according to the United Nations, we will be up to about 9.8 billion potentially by the year 2050. In order for us to continue feeding all of these people, as we have a responsibility to do, we have to continue to become more efficient and more effective in the ag industry. It benefits our world, it benefits our country, it benefits our families. And so that kind of tells you what we'll be studying for the next weeks or the next few lessons. The big question becomes the big question becomes, what are some of the new and innovative approaches that can continue to improve efficiency and effectiveness in agriculture? We know that the Earth's population is projected to grow by another 2 billion in the next 30 years. Experts say in this publication called The Future of Food that we will need to produce as much as 56% more food to feed everyone. So that's just in the next 30 years. We have some work to do. But let's be real, we've always had some work to do to feed people. These are pictures of farms from about the year 1920, and I want you to take note of a few things. Perhaps if you're in a classroom with a different teacher, you'll pause me here and discuss this yourself. But I noticed some things right away that talk about the efficiency and the changes we've seen in agriculture. If you study the picture in the left, I picked it on purpose because it had a whole bunch of people in the garden. This is just a single family's garden, but most of the family and the extended family is in the garden helping. And really, this picture symbolizes the fact that in 1920, it took far more manpower to produce the food we eat than it does currently. There are a few reasons for that, which we'll discuss later, but you can see people of all ages, you can see people of all types, all working in the garden. On the right, you'll see a picture of some mules. It looks like helping with the field work. In this particular situation, they're cultivating, and it's a very looks like prosperous field, but it's also symbolic of something we know from that time, and that was that we didn't have access to tractors, and so the look of agriculture was significantly different. If you've studied in your history class, you know that at that point in time, most of the population lived on a farm and was responsible for coming up with their own food. Although we were starting to see a little bit of specialization and people purchasing or trading for foods in small towns. Let's contrast that with our current state. 100 years later, this is what agriculture could look like. What are the things you notice? What are the changes you notice? The picture on the left is a picture of a hydroponic cultivation site for tomatoes. They're produced under glass in this situation. They have a very specialized watering and nutrient system, and the water is recirculating underneath. The picture on the right is actually just a stock photo, but it really is symbolic of what you might see all over the Midwest during harvest times. Multiple mechanized harvesting machines working on a field together, very efficient, very effective use and collection of the grains, which enables us to keep the prices low or as low as possible for food and other feed production. We notice there's less people in the pictures because one person can do more work with the help of the technology that we have available. We know that agriculturalists have always been problem solvers, and so I have full faith that we will continue to be problem solvers. Today, I hope we'll take some time to look at a few examples of problem solving. They say that necessity is the mother of all invention, that oftentimes the best inventions only came because there was a problem to solve. The first picture I'd like to show you is a picture of a cotton gin, or parts of the cotton gin, if you will. It was invented by Eli Whitney, and he was a recent graduate of Yale. He thought about becoming a lawyer, but he had a lot of debts to repay, and he needed a job quickly. And so he left his um, his home, where he had always grown up in Massachusetts, and assumed a position of a private tutor on a plantation in Georgia. And so his responsibility was to um, educate the children there on the plantation, the young people. The plantation owners made it very clear to him that they were looking for a way to make cotton growing more profitable. And they were doing this because the tobacco profits were declining. There was kind of an oversupply. They had exhausted the soil, and cotton needed kind of a workover, if you will. Long staple cotton is what it was called, and that's easy to separate from the seeds, but it could only be grown along the coast. And they had one variety that you could grow inland further where he was, but it had these sticky green seeds that were very time consuming to pick out of the fluffy white cotton balls. And so Whitney was actually encouraged to find this solution to this problem by his employer, who was a plantation owner. Her name was Catherine Green, and she actually supported his early prototypes. And that is the real reason that we have the cotton gin is because a problem needed to be solved. Another example of a time we've used it throughout history when we've needed to solve a problem actually had to do with greenhouses. We know that the Romans used some greenhouses, and it really only came to be because one of the royal physicians recommended to Tiberius that he eat one cucumber a day to restore his health. He had been very ill. This was easy in the summer, but when it came to wintertime, everybody was very worried about how they would keep his health up. And so they created this alternative solution that later became a greenhouse. They grew structures, and then they kind of covered them with this translucent material. At the time, they used like a thin oilcloth um, or a piece of crystallized kind of mineral gypsum that would allow the sunshine in while preventing heat from escaping out. Now, greenhouses are a very important part of our society and our food growth. One last example, necessity really is the mother of all invention, and one example of that is the early plows. In the United States, some of the earliest plows were actually as simple as a crooked stick with a kind of a iron point on it that would scratch at the ground, and they were not very efficient. They were not very effective. In about 1812, some other plows kind of came. People became a little bit more creative, and they would use a bigger chunk of wood or something a little tougher. They had to come up with a deep furrow so they could plant the seeds deep enough to get successful crops. And so that necessity caused them to try all sorts of different things. People used chunks of really tough wood, they would cut it into different shapes and attach them that way. No two mold bores plows were the same. None of the curves were the same. But they eventually came up with one that worked, and they began to make them repeatedly and found it so that the curve worked perfectly to furrow the soft ground, and it had little enough friction that they could get the dirt to come off of it and continue plowing. And so those early plows later became part of the John Deere era tractors. Even in history, the human brain naturally uses this problem solving model. And you'll find that you yourself use this problem solving model all the time. We first identify a problem, and then we kind of think of things we can do to fix it. We pick a solution, we try it, and then we see if that's going to work well. Take the example of you want to go out with your friends, and you ask your parents, "Can I go out with my friends?" They say no, because your room is filthy dirty. They have defined your problem for you. You brainstorm solutions. You say, "Well, if I clean my room, can I go?" And you kind of go back and forth. And finally, they say, "Sure, if you clean your room and empty the trash and um, wash the car, you can go out tonight." You decide whether or not you're going to take that solution, you implement it, and then you review the results. Now, that was a very simplified model, or a very simplified example, rather, but we use this model in our brains all the time, and it is the same problem solving model that I'm going to encourage you to use as you go through this unit of instruction, because we're going to start looking at different technologies that have improved agriculture. But in the end, your ultimate job is to find new technologies and to brainstorm new ways that we can become more efficient and effective at producing food. We're going to try it once with a candy bar. You'll be given a small candy bar and some tools to open the candy bar, but there are certain rules. So I'm going to let your teachers set up that lab for you, and then you can move forward with that. Finally, I want to make sure you understand our task for this unit. We are going to create a series of labs in this unit, or complete a series of labs rather, that will explore some of the more recent ag technologies you may know about, or you may be surprised to learn about. Your real goal in the end of the unit is to come up with a potential advancement that we can make, a new invention, a new idea, a reformed idea, an improved idea. Because ultimately, your generation has to decide what new and innovative approaches that we can use to continue to improve the efficiency and effectiveness in agriculture. Before we go on to those labs, I want you to take a few minutes today to study other people who have been problem solvers throughout history. I think you will notice that you have some traits in common with them. I think you will notice that they have some traits like perseverance and stubbornness, and that they were inspired by people around them, but that they also had their own share of struggles. And those struggles really gave them even better problem solving skills. Your task is to choose one of these individuals, do a short study of them, about 10 minutes, and then you're going to report back to a group that you're assigned to. I want you to be able to share with your group what made Norman Borlaug really important. How did he affect agriculture? But more importantly, what traits did he have that we can mimic to continue to inspire and improve agriculture?